Guys, here is yet another Megadrive, PAL Megadrive system that I got from that pile of non-working. God, the scratching in here. I'd say they were piling on top of each other and probably just that top rubbed, because it's something I've seen on a few others. Anyway, here the sticker says MK, not sure what that means. Maybe Mortal Kombat, that's what the test is. Second player always moves right. Is that specific to MK? That would be a connector issue then. If it was game specific, that'd be a card issue, but doesn't say that it doesn't start. So I assume there's probably a problem with the joystick input for player 2. So this guy. But let's open this up and see what we have inside. Well, no, actually first, let's see if that claim is true. If the player actually moves right or left or wherever all the time. So I'm going to plug this, maybe use Streets of Rage because it's here, and I need to dig out the second controller. Let's do that. So here we need the second controller available for this to be an option. So yeah, whatever, start, doesn't matter. I just want to see that player 2, which is Blaze, is indeed always moving right. Yes, she is. I can. She's moonwalking now. Yeah, but it's like the input for right is stuck, but it's not. So fair enough. That's enough for me to see. So, guys, let's open this guy up and whoa. So let's open this guy up and see what we have. I will speed up this entire process because by now you probably know already how to open the Megadrive. If you don't, watch one of my previous videos where I show you how to open it, or watch this in slow motion somehow. So here it is. This is our two controllers. I don't see any other components on this actually. I didn't think there was. So these don't look like, I thought they might be pull-up resistors and caps, but these look like, are they line filter of sorts? Just to prevent, hold on, let me get my continuity I assume these are not even really discrete components and are more just a filter of sorts, so we should have straight continuity between these. Yeah, so this is not even, it's probably a filter of sorts, but these are not resistors or the capacitor that you'd find in a standard setup. Let me explain this actually. Let me draw you, I'll clear this up. Let me draw you what I'm talking about. There you go. You have to understand what a controller is. It's essentially a collection of switches. Your standard Megadrive or NES controller essentially just connects a common ground to one of the direction or button lines. So you have, let's just say we'll draw the Megadrive, and I'm doing this through my phone, which is again not ideal. Connector here at the Megadrive entry. So we have I think there's 5 pins here, 1 2 3 4 5, and there's 4 pins here. Anyway, one of those pins is I think +5, but the other one is ground, and here I think this one here is actually right. For argument's sake, we're left, up, down. I'm not sure if that's correct, but it doesn't matter. So what we're doing when we are actually pressing right or pressing a button is we're connecting ground to one of these guys here. I'm not sure in this case what the +5 is. I could be wrong, but I'm describing it from the standpoint of most arcade machines and most 8-bit type computers. I believe this is the same. Essentially, we're just grounding this line here. So we can represent the switch as something like that, or sometimes it's sometimes it's something like what am I doing? It's something like this. That will actually just connect the two lines. It doesn't matter really. If you look at your controller, the PCB on your controller, you'll probably see a trace that goes, I don't know, for keyboards it can be something like this, and then there's a trace here in between those traces. And so one of those is connected to ground and the other one is your key or whatever it is. And what you have at the top is a carbon pad, and when you press the button it actually connects the two lines like that. So anyway, that's beside the point. So this switch here is connected to ground. And to simplify things here, we have this line, which is, we'll just say it's right for argument's sake, is going typically to a buffer type stuff. A buffer, which there's an enable line here. So the buffer will get the signal, and when you're grounding, you're actually sending 0. So the buffer gets 0, it keeps 0 until the enable line is, and then sends that to the CPU or just a processor of any sort, typically. So it needs a 0 to be active. It's called active low in this case. So that's what when you're pressing a button, that's what happens. However, when this is open, so when we are not pressing, essentially what we have is an open circuit. I mean, we're sending here. We've said we sent 0 to the CPU, but what are we sending here when the button isn't pressed, when there's nothing coming from here? You would think it's 0 as well, and it's probably one of the misconceptions about binary 1 and 0s. People assume that, you know, information is 1 and no information or the lack of information is 0, and that's not true. The lack of information is actually floating, and this is the case here. We actually don't know what this line is doing. It's floating. It could actually be statically, technically, it could be statically charged to 1 or to 0 or to any other value. We actually do not know, so it's floating. It certainly isn't sending 1, certainly isn't sending 0. So this is information. 0 is as much information as 1 is in electronics, and the lack of information is floating. People often think there's only 2 states in electronics. It's not technically true, there's at least 3. Anyway, that's again beside the point, but it's important to know, so because that means that when we're not pressing a button, we need something to force this here to 1. And in this case, what we do is we put up a pull-up resistor, or let me go back, we could connect this straight to a 5 volt. If we did that though, we get straight 5 volt, it's gonna heat up really quickly, we might fry up our buffer. Fresh sheet of paper. Anyway, so what we do is we have our switch. One side is ground. People get upset when I do ground one way or another. So we've said we 1, 2, 3, 4, 5. 1, 2, 3, 4. This here is the ground. So this is actually here, this one. Yep, sorry. And then here we're sending this to a buffer, and that's outputting to our CPU or any processor. And here we need, when this is not pressed, we need this to be connected to 5 volt to force it to 1. So this is called a pull-up resistor. You can have pull-down resistor as well, and then connected to ground for the, if something is active high. 5, and typically you'd have some capacitor here just for voltage regulation purposes, I believe. Anyway, so this is a typical setup, and when you have one of these, what you have typically is, if you look here, you'll have an array of either resistors and capacitors. You can certainly see them on most arcade boards. Let's see if I can dig one here really quickly. So there you are. These, you see these arrays? This would be a typical setup. We're getting our connectors here. We'll have a joystick here coming, which are our inputs. All these lines would probably go to one of these resistor arrays, and this is what they are. and maybe they might be sharing a common capacitor. I'm not sure, but or might be not there at all. But this is our pull-up resistor arrays sending to these buffers. Yeah. So this is how it's done here on PCBs. In this case here, we have those EMI filter things. So I don't see a resistor array or any capacitor. So I assume that these signals are being sent to one of these guys, probably this guy here. So first thing I want to do is, but you see how you can correlate. So essentially all this job here of pull-up resistor and buffering is probably done by this or this guy. I assume this is this guy because this is video, isn't it? So what I want to check is whether this line here, which is our right, is shorted to ground, so already connected to this. I'm hoping it is, because then we can actually trace that back to somewhere. If not, it might actually be coming already wrong from this guy. This guy might be faulty and sending a 0 already. So let's do a few measurements and see if we have things shorted. I thought I would actually demonstrate what I've been preaching by showing you what happens when you press a controller. So I have the probe on one of the controls there, and if I'm not sure which one it is. There you go. That's right. Sorry, that's left. So whenever I press left, signal goes low. So it's high all the time unless you bridge it to ground, and it becomes low, and then that's interpreted by the processor as having received a signal. So there you go. I thought I'd show you that. Oops. Yeah, I want to check if there's any continuity between ground here. Now, this is our ground, fine. And is there anything here? No, so it's not. Yeah, it's not grounded. I believe these guys here are connected. That might be easier to one of these. We got these pinholes here, and they're what, first one round. Okay, so this connector here is going all the way up here to one of these guys. Yeah, okay, let's check if this is grounded, which I suspect should be. Or it's not grounded, but it's at 0 from somewhere else. And yeah, and then if I select, one of those, which one is it? Yeah, there you go. So I'm right on the pen, and this is set too low. So what that tells me is there's a problem with this chip. The good news is we've identified what the problem is. The bad news is, once again, this is a custom chip. This is a Sega custom chip, and well, there's no repros that I know of, and partly because this is such a fine soldering technology that you need to factory make them. You can't just repro them from your house, really. So that would be cost prohibitive. So the only way to fix these really is to get a donor one from, I'm going to switch the power off here, to get a donor one from another machine, essentially. And usually, I would need to find a machine that has a working one of these, but maybe a defect one of these, and you salvage one and you sort of Frankenstein a new working Megadrive together. But that means that I can't do much beyond this point. Now, the good news is this is just player 2, so it only affects games that need 2 players. This Megadrive still works if you're playing a 1-player game. I can still enjoy this. But what I might do is just use it as a donor board of sorts, unless I find a Megadrive that has something else wrong. If it's just a processor, you can find these and replace them. I'd rather buy a new part to have a working Megadrive, but if you find one that has, say, a working one of these but a dead one of these, then you can from the two make one. Anyway, long story short, this is for now going to be a donor board. I'm going to set that on the pile of scraps and bits. And move on to the next project. Hopefully at some point, maybe somebody has a spare one of these, or I'll stumble upon it working one of these from another project. Anyway, folks, I hope this was of some interest, and well, maybe some of you have learned a bit of stuff, about electronics in general or the Megadrive. I know there's a wide range of people that watch these videos from people who don't know anything about electronics but have some curiosity, and there's a few people who are far more knowledgeable than I am, and probably pulling their hair at my poor explanations, but it's never intended to be an authority on electronics. I'm certainly not. I don't claim to be, but I have an interest and I like fixing these things. But anyway, thank you for watching. Don't forget, you can join in on the Discord server, Instagram, Facebook, Twitter, and there's also Patreon if you want to help me, get parts and bits and support the channel. Folks, thank you for watching, and I'll see you next time.